Hi, in this session I am going to discuss estimation of parameters using maximum likelihood estimation, in short known as MLE. One of the frequently used methods for estimation of parameters of probability distribution is the maximum likelihood estimation. The main advantage of MLE are that it is mathematically rigorous and it is less susceptible to individual values, and each data in the sample holds equal weight in the calculation of estimates of the parameters. The method is very robust and thus can be used for any distribution. Pearson in 1936 demonstrated that MLE provides better estimates than the method of Muenz using few examples. The method starts with a belief about the probability distribution of the data and estimates the parameter that maximizes the likelihood function of observing the data given the distribution. MLE has the following steps. The first one, start with a belief about the population. Say the data follows an exponential distribution, that is the belief. Second, derive the likelihood function that estimates the probability of observing the data using the belief in the step 1. In third step, we take natural logarithmic transformation of likelihood function or log likelihood function. Log likelihood function is used to simplify the computation. The fourth is estimate the parameters that maximizes the log likelihood function derived in step 3. Let us look at how we can use MLE for estimating the parameter p of a binomial distribution. Let us consider a binomial distribution with n Bernoulli trials, each with success probability of p. The objective is to estimate the probability p. The probability mass function of a binomial distribution PMF of x is NCx p to the power x times 1 minus p to the power n minus x. Here NCx is n factorial over x factorial times n minus x factorial. Let us assume x1, x2 up to xm be the number of success obtained out of n successive trial repeated m times. The corresponding joint probability is the likelihood of observing x1, x2 up to xm success out of n trials repeated m times. The likelihood function L of x1, x2 up to xm given p comma n is nothing but the product of probability mass function xi, where I is from 1 to m, which is same as I equal to 1 to m nc xi p to the power xi times 1 minus p to the power n minus xi. Now, we can take the log transformation of this function. When we take this, we get this summation. So, this is the log likelihood function, and we have to take the derivative of this log likelihood function with respect to p and equate that to 0. When we take the derivative of the log likelihood function, we get the value as 1 over p summation I equal to 1 to m xi minus 1 over 1 minus p summation I equal to 1 to m n minus xi, and we are equating that to 0, and when we simplify we will get the value of p as summation I equal to 1 to n xi over m times n. So, that is the estimated value of p using maximum likelihood estimate.